Is that my good to go? Awesome. Welcome, everybody. Thanks for spending some time this afternoon with me. My name is Todd Gardner, and what I want to talk about today is smashing JavaScript bugs, debugging client-side JavaScript errors. Because we probably are all writing some JavaScript, right? Is everybody writing JavaScript? Yeah? It's kind of scary sometimes, right? Because you're not entirely sure what's going to happen. And you deliver these applications out, and then when they go wrong, you're not always sure how to deal with it, because there's a lot of different things that can go wrong. And so what I want to talk about today is we're going to do some live coding together. Not so much live coding as live fixing bugs. So I've personally helped fix over 32 billion bugs. And I'm kind of inflating that number because I run a company called Track.js. We have a booth out there if you haven't stopped by to visit us. And we help all kinds of customers understand the bugs that are happening in production for a bunch of really cool companies. So if you want to check us out later, that'd be awesome. We could chat. But so what I want to talk about today is something else. I have this problem I see out in the market that I think we can fix. How many of you have experienced this rage? Someone is wrong on the internet, and we have to go and fix it. We have to prove them wrong. But more often than not, that gets us into trouble, right? You end up in an internet argument that you probably shouldn't have started. And so I have this idea on how to fix that problem. And so I want to show you all my next business idea. Are you ready? GetRanter.io. And here it is. This is really cool. Blow you out of the water. This is GetRanter.io. And it's kind of like Twitter. It's got like your profile. You can say like, how long have you been ranting? You can like add new things. You can talk and spit stuff out into the internet and get all the rage out. And we can see a timeline of all the things that you've been upset about over the last couple of days, months. And I even have like my monetization model already in place. I have these awesome targeted ads that like follow you around the internet, and they know exactly the things that you want to buy. So this is my account, and so obviously I'm really into bears and Crocodile Dundee and bacon and oddly David Hasselhoff. But like it's targeted. That's what I want. And so I think this is going to be awesome. This is going to just blow up. But unfortunately, I think GetRanter has some bugs in it. And so I want your help today. We're going to go through this, and we're going to fix a couple of things in it. So obviously, this is Silicon Valley's next unicorn startup. You know, we're going to be $1 billion next year. You're all going to be like, wow, I saw the first demo of it, the first one. I was there. But so I really hate bugs. That's going to kill my startup if we get this thing out the door and there's still all these bugs in it. So there's 5 of them in this app, 5 different classes of bugs. And so we're together going to go through this thing using live developer tools, and we're going to bust this thing open, walk through the steps to identify the problems, find them in code, see how they manifest themselves, and fix them. Does that sound good? Is that pretty close to the expectations you had coming in the door? I'm happy because that is the only thing I am prepared to present to you right now. All right, so here is our very first bug. The user cannot delete a rant from their timeline. Somebody said something that they feel they'll end up regretting, and they want to get rid of it. And right now there's a bug that prevents them from doing it. So we're going to talk about 2 different things in order to fix this bug. We're going to look at the Chrome DOM inspector and the JavaScript debugger. So let's kill this bug. So we're going to switch back over to GetRanter. Now, one of the first things that I always do when I'm trying to troubleshoot a bug in real life is I want to look at real data. And so this is my account on GetRanter, but you know, I'm the developer, and so my account's always a little bit weird. You try out, you have interesting use cases. So I want to use one of my most prolific users as my test case. So, you know, as an admin, I can switch, you know, the user that I'm dealing with. So I'm gonna switch that out, and load one of my big customers, and we'll see how well it does for them. So this is one of the biggest customers, the biggest users of GetRanter, and so he's been using it since March of 2009, and obviously you can tell that my ad targeting is just spot on, right? Like, it is clearly a good target for my customers. But so let's use this customer as my basis for fixing this bug. So the bug was that the user can't delete one of their rants out of the timeline. And so here's the timeline, and there's a pretty obvious like delete button there. So let's just give it a try. Let's just try and delete something and see what happens. So here Mr. Trump was railing against Congressman John Lewis a few days ago. And so we're going to try and delete that one because that's obviously something that he probably regrets at this point. We delete that, and we just kind of see the page reloading, but nothing's really happening. Although I do get a bunch of new ad impressions every single time he does that, so I'm making a little bit of bank off of the whole situation. So let's start with the DOM Explorer to figure out how to do it. So you pop open the Chrome Developer Tools. How many of you have spent time in the Chrome Developer Tools? Yeah, all right. How many of you feel like you already know all the stuff in Chrome Developer Tools? All right, well, hopefully I can show you a few tricks along the way. All right, so here in the main Elements panel, we see a bunch of information about the document itself. We see all of the different markup that makes up GetRanter. And so what I want to do is I want to see what's going on with the delete button itself. So I can use the selection to go into my document and pick a certain element, and I can get some information about it. So let's grab this delete button. We can see that the delete button itself is a button element inside of a form with a bunch of other things. But I can get a bunch of other information about it. Like, what I'm going to do is I want to see who is listening for events on this button. And so we can punch in here to event listeners. And we see that somebody, at least in the ancestors of this element, is listening for a click event on the delete button. So we can punch in and we say, hey, somebody at the div level, so a couple of objects above this, is looking for a click, but it's just something in jQuery. That's not really particularly helpful. This little checkbox here allows Chrome to navigate through a bunch of the event management frameworks and tell you the actual code from your app that is listening to it. So by turning that on, we can actually see that some of my code here in this rant list view.js is what is actually doing the behavior through jQuery. And so we can punch through and take a look at what's going on. And by doing that, it bounced us over from the Elements tab to the Sources tab. And the Sources tab allows us to actually see the source code running and punched us straight through to the line, which is right here on line 19. Line 19 is we've set up a click handler using kind of a jQuery-esque syntax that, hey, when somebody clicks on an element, we're going to check to see if that element matches a particular pattern. And then if it does, we're going to call an onDelete function. This is an event delegation pattern where you can listen for an event at a higher level than where it's actually going to be originating from, and then check to see if the event target matches the event you're looking for. It allows you to centralize some logic and attach fewer listeners on the page. So let's attach some breakpoints here and see if we can debug what's actually happening. So we'll go ahead and attach a breakpoint right here on line 20, and you can do that simply by interacting here with the line numbers. With a breakpoint attached, we can go ahead and try and hit the delete button again, and we're able to catch that the event happened. We've dropped in here to our event listener function, and we can see all kinds of interesting information about the current running state of JavaScript at this point. So in these sections down here, we can see information about local variables. We can see what is the event object that originated, and we could explore and see more information about it. We can also see anything else in the local namespace, like what is the current value of this. And then here on the left, we can see the call stack. So we could see what are the things that originated this function. So we see that right now we're calling into an anonymous function, which would be this function that was defined here without a name is the anonymous function. That anonymous function was called from deep inside of the bowels of jQuery. Now we don't really know what happened before that, which is kind of interesting, like where did this event come from? Chrome DevTools, in maybe the last year or so, introduced this checkbox right here, this async checkbox, which is off by default because there's a slight memory pressure that it introduces on your local computer when you turn it on. But if you have a developer class workstation, it's totally worth doing. By turning it on, we can see a whole bunch of more information about where this current JavaScript execution stack came from. So if we go ahead and just, with this turned on, we just need to reload the page to make that take effect. Our breakpoint should still be in place, and if we hit the delete button again and get, oh, that didn't work the way I wanted it to. Moving right along. Okay, so here let's take a look at the actual code. So the actual code that we have operating is where we get this event, and the event is a click event on a button. And we can step through this. There's a bunch of controls down here about how do you want to step through code. Do you want to just step over the functions or step into the functions or step out of the functions? And that should be, are most of you C# developers normally? Is anybody not a C# developer normally? What are you? All right, but same kind of tooling, right? So the debugging of step over, step into, step out should be pretty familiar, right? So Chrome gives us all the same things. If you do this a lot, you should totally learn the key commands on how to do it, so you're not always trying to find this little toolbar. So we can step through this and see that the event target did indeed match the query JS delete. And so now what we're going to do is we're going to call the onDelete function. So I want to see what that is. Let's step in to the onDelete function. OnDelete is a function that does not take any arguments, prints some snarky message, and then destroys some stuff. Now, even though it doesn't take any arguments, I'm pretty sure where we were before we were passing something into it. So because we're broke inside of a function, we can use the console to live evaluate inside of it. And so I want to see what the value of arguments is right now. Arguments is a magic parameter that happens inside of JavaScript that we can see how was a function called even if those parameters were not declared. So the arguments that we got is we actually got an event, and that event is the click event that originated this thing. So, but we're getting this click event and we're not doing anything with it. We're just, ignoring it, and then we're trying to destroy and remove out all of the stuff having to do with it. But if we recall, I think if we bounce back here, back in the elements, the button that we're clicking is inside of a form. And when you click a button inside of a form, what normally happens? A submit bubbles up. So we're submitting a form, and that's what's causing a page reload. So I think we need to make a few tweaks in our code to stop that submit from handling and let our code execute normally. And so I have a bunch of context going on right here about how I'm fixing this bug. And so I don't want to punch out into a different IDE. I want to just fix my code right here. And so Chrome lets us do this with workspaces. So I can take Chrome and attach it to the live files on my computer and make modifications. And so from the sources that I'm interacting with, I just want to add a local folder to my workspace. I keep all of my stuff inside of, projects. The original name of GetRanter was Soliloquy 2, so we're just going to attach it right there. And I want to, now we see, I have to give access to Chrome so it can access my hard drive, because Chrome by default doesn't want to talk to your hard drive. And now I should see that I have a folder here in my sources tab. Even though this folder isn't served directly by the website, Chrome can link it up and I can see it as a set of sources. And now I actually want to link these two together. So there's a two-step process here. First, you have to add the folder to your workspace. And then what I want to do is I want to map this file, this rant list view that was served from my server. I want to map it to a local file resource. And by doing it, it'll automatically try and match it up by name. And so it found a file called rant list view in project soliloquy 2, source, public, scripts, etc. And so I want to go ahead and add that. And then I'm just going to do a quick test here to see if this worked. So I should just be able to live edit this file now. And I'm going to do some old school how do you test that changes worked? I'm just going to add a block alert right in there and hit save. Let's reload the page. Oh, there we go. Hey, NDC. Off and running. Projector's kind of flaking out, guys. All right, so we're going to keep going and ignore that that's happening for now. All right, so we can make live changes to this file. So we were able to save the rant list view. So now what I want to do is let's define the parameters that this thing is getting passed with. So onDelete gets an event passed into it. And in order to prevent this click from bubbling out and becoming a submit, we need to prevent its default behavior. And so that's just a standard function on top of JavaScript events. So event.prevent default. So that right there should stop the behavior of a form submit and stop the reloading of the page. Let's confirm that that's happening. This seems to be getting worse as we progress. Is there anything we can do about that? No? All right, we're just going to keep going and ignore it. All right, so now let's give this thing a try. So we hit delete. I'm just going to stop the breakpoint for now and just let it go, see if we fixed it. And we did not fix it. But it's not reloading the page anymore. Now it's just puking out an error. Type error cannot read property destroy of undefined. But now we can go in and we can start debugging the next step of this. So here, right in the console, it printed out an error message. And from that error message, we can explore and see what this is. So it says that cannot read property destroy of undefined at rant list view line 35. It was some anonymous function called by set timeout, which was called by onDelete. So we can navigate right here from the console, and we'll punch back into the sources tab. And Chrome, very nicely, even highlighted the line that broke. It's saying, hey, I tried to call this thing, and it wasn't there. Cannot read property destroy of undefined means this was means that model was undefined at the time this thing executed. Does anybody know why that might be? Yeah. Because this is not what you think it is. The trick here is that I used the keyword this inside of a callback function, which is one of the most common JavaScript errors that just about everybody in the world still makes, right? So because we've passed a callback function in, when that function is called, the value of this, the context of that function, is not really what we expected it to be. This code obviously expected this to be the object that onDelete is operating on. But it's not. It's probably window, or it's null, or it's some global object that is definitely not what we expected it to be. So let's fix that. There's a couple of different ways we could do it, but this is 2017 now. We can use some new cool JavaScripty things. So what I want to use is I want to bind what the value of this should be when the function executes. And so to do that, what I'm able to do is functions have a function that you can call on them called bind, which permanently glues together what you want the context to be when that function executes. And so I want to bind the value of this on the inner function to the value of this on the outer function. I want to guarantee that this callback function uses the same value of this that I have on the outside. And so by gluing those two things together, and I can just hit save because everything is attached together in a workspace, I should be able to give this page a reload. And let's see if we can get rid of that pesky Congressman John Lewis rant now. Oh, there you go. I told you you'd regret it, but does anybody listen to me? No, I'm just a hyper-intelligent JavaScript computer. Sweet. We fixed the bug. Now we can go through and delete a whole bunch of statements that he might regret later. So, here was our bug number 1. We talked about the DOM inspector. We talked about the JavaScript debugger. We fixed this thing by adding 2 different kinds of things. First, we had to prevent the click event from triggering a form submit, and we had to bind the context so that we had the correct value of this. Let's not stop there. Let's keep going. We got another bug. The rant text. Somebody goes and starts typing a bunch of text in the rant, and we have some cool functionality that, like, if your page accidentally reloads, we'll remember what you were ranting about so you can reload it next time. But the problem is, like, somebody gets all paranoid about what they're writing and deletes the whole thing, but we still remember it. It's still there. So I think to fix this one, we're going to need to take a look at the Application Explorer, and because just about everything requires it, we'll be in the JavaScript debugger again. So let's kill this bug. So let's reload here. Let's make sure we're clean. So the problem that was described is that I should be able to write a bunch of stuff, and if I go ahead and just reload the page, it's still there. Like it's being remembered. And how we're able to do this is we're saving these values in storage. So we can take a look at some of the other Chrome functionality here, which is the application capability. The application capability lets you look at all of the different things your web browser or the web page is storing on your local machine. So things like local storage, session storage, cookies, and the index DB. So GetRanter just uses local storage. So we're going to take a look, and there's just a key right here called next rant, where we're just arbitrarily storing the text. And you can even see as we type, you can see the value changing inside of next rant. If we wanted to, you can even interact with local storage and change the value on the fly. Of course, I don't expect that behavior in GetRanter, but if we were to reload the page, we would see that, I did a keystroke, dang it. If we were to now reload the page, you would see that the value from application is now pulled in. But so the problem of this bug that we're facing is that if we type some stuff, that we might regret later, this is all saved in storage. And so, like, if I decide, you know what, I do not want to post that, and I just zero it out, if I reload the page now, it's still there. It comes back. It's like I can't get rid of it. Every time I delete it, it just keeps coming back. And so let's take a look at, again, how is this happening? So we can take a look at this particular text area, which is where we're pulling stuff up, and take a look at the listeners again about who is interacting with this. So the event listeners attached here is we have a submit and we have a key up. Key up sounds pretty good. Now, key up, somebody is listening to it, but somebody's listening to it with Lodash. And unfortunately, the framework listeners doesn't know how to, like, navigate through Lodash, which is not so cool. So instead, let's just take a look and see if we can figure out who is interacting or who is finding, who is using the key up statement. So if we go back over to sources, and we use the Chrome search functionality, we can actually just search through all of the sources and see if we can find something we're looking for. So I'm going to search for the string key up and see if I can find some stuff. And I find one right away here in add rant view. Looks like we're attaching some sort of event to the key up on text area. So the key up on text area is going to call a function called onChange. So onChange takes an event, And that event, we look to see, what's the target of that event, which based on how we declared it should be the text area, hypothetically, right? And so the text area should have a value, or it might be garbage, in which case we get nothing. And so if we pull some text out, if there's text in there, we set the item in local storage. So it seems like it should function correctly. Let's maybe put some breakpoints in there and see if we can figure out what's going on. So we'll attach there on 16 and type some more characters. And we see we caught the event. The event comes in, and Chrome lets us just mouse over different elements, and we can just see the values in line. It also prints these fancy things like right here next to things, so you can quickly examine what the values of different variables are. But so if we mouse over here the target does look like a text area. And if we even go out, if we step to the next level, we can see that the text is the contents of that text area. And so we're passing it into an if condition, and we're just evaluating its truthy or falsiness. And so it's a string with text in it, so it should evaluate truthy, and we will set the item. So that looks all right. So let's try it in the bug case now. So we're going to clear it out. All right, so now we're going to get the text again. And the text is empty string, because it's gone. There's like nothing there. So empty string just thrown into here is going to, it falls right out of that if conditional, and it never sets the item. And so the condition here is an empty string is falsy, and even though that condition is just trying to protect us from setting bad values, we're not clearing out the value. So let's go ahead and stop this and see if we can change it. So maybe, what should we change this to? Well, I mean, we could probably, it might be a superfluous check, so we might be able to get rid of it entirely. Or we might want to check to see if it's a string, and if it's any string. What do you think? What should we do? Length? If it has a length, that's not bad. If text or an object, because if text ends up being undefined, I'm pretty sure undefined.length is not a thing. But JavaScript is weird, so you never know. It doesn't look like it's a thing. So text or some object.length. Although length, what's length going to be of empty string? It's going to be 0. And so what's 0 going to be if we drop it into a truthy or falsy operation? It's still going to be false, and we're going to fall right out. So that's not necessarily going to work. Yeah, so what would be the type of string? Oh, well, maybe we could just do that. So maybe we'll just do type of text equals string. So if we get any string off of it, we want to save it, even if it's an empty string. But if we get some garbage value due to some weird browser quirk, like if it drops off undefined, or it drops off null, or it drops off 0, or, browsers do terrible things sometimes, then we don't want to save it. But as long as we get a string, no matter what that string is, we probably want to save that. So let's give that a try. And because everything's wired up, we can just save it right out to the environment. And we'll give this another go. So we put something in there, and it's saved. Let's put our breakpoint back on there. And now we're going to zero it out. Oop, that's not what I wanted. Sorry. Stop going off. So now if we zero it out, the key up event goes, and we check event target, and we get text of empty string. And the type of text empty string is string, which is obviously equal to itself. And we're able to set the item of next rant to empty string, and everything continues on its merry way. So now we're able to zero it out, and it's actually gone. So what we took a look with here was we looked at Application Explorer. Yeah. Yes, because the question was, if we were to type a number into the field, would it still be a string? Yeah, so let's actually just play with that. That's a good question. So we put 3 in there. The value of text isn't 3 the number, it's a string using the 3 character. So it would only become a number if we explicitly cast it or coerced it into a number type. Anything that comes off of the DOM is probably a string. So what we looked at here is we looked at the Application Explorer, we looked at the JavaScript debugger, and we fixed this thing with falsy and empty string. So let's take a look at another one. So the server is reporting a lot of 400 requests. So my server-side team is complaining a lot. They're getting a lot of 400 requests. So let's take a look at the network inspector and the JavaScript debugger to see if we can recreate this. We'll continue. Let's get rid of that breakpoint and keep on rocking. All right. So we're going to pop open the network tab. Now the network tab lets us see all of the different requests that our page is making in order to construct itself. And it's got a lot of things we can do. We can see a timeline of all the things that are happening as part of load. We could filter this down to say, hey, I only care about image requests right now, or I only care about AJAX requests right now. But so if I just take a look through this on a normal load, I'm not really seeing any 400s. That would be like an error response, and I would expect to see it in red, but I don't really see anything. So maybe let's try just interacting with the app a little bit, see if we can create them. So I added a rant as Donald, and nothing really happened. Maybe we delete one. No, that didn't really change it either. Well, what happens if we just click on rant? There we go. So if we just click on the rant button by itself, it kind of just blows up. So here we can see all of these 400 requests right here in the network tab, and we can explore them. We can see that the status code that the server is returning is this 400. We can actually see a whole bunch of information about it. We could go in and we could see what is the piece of code that is triggering this. We could even see the stack trace going all the way back to say what exactly is making this AJAX call. Right now, let's just take a look at the request itself. So here we have a request going out to, we're making a post to API/rants. It's coming back with a 400. And we can take a look at even the response code. And the server is even telling us kind of what's wrong. So my server team did a pretty good job of actually giving error responses and said, hey, we're not going to let you post anything where the text is empty. So if they're not going to let me post it, I should probably prevent myself from doing it. So let's go back to just the listing, and I want to look at the code that's causing this request to be made. So by mousing over this, I'm able to bring up this history. And so there's some junk that I don't care about. I didn't write jQuery, it's not me. I didn't write that jQuery, it's not me. I didn't write Lodash. There we go. There's one of mine. Add rant view. Add rant view. So there's something with the framework that I'm using must be triggering this AJAX event, because the only call that I'm making is a this.collection.create. So I'm adding a rant to a collection, and it's got some text in it. But I'm not doing anything I'm not validating it. So if I just put a breakpoint here and hit rant, the collection, I'm trying to create a value from text of rant, or a form.rant.value, which is empty string. So I really just need to put some safety checks around this. I shouldn't send an invalid value to the server. So we can just jump in here and make that modification maybe. So maybe we'll say if form.rant.value. Now in this case, we could probably get away with a falsy value, because really the thing we want to prevent is an empty string from being sent. So if there is no value there, then maybe we just want to return. Let's just have an opt-out. In fact, maybe we should put that maybe even up here before we print out some snarky messages. So let's put a defensive statement in there, this form.rant.value, and we'll punch out. And I hit save, and it reloads this function. So now we're going to come in, and we prevent the default behavior. Oop, I stepped into instead of over. So now we have the form, and we can check if form.rant.value, which should be a falsy value, and we bounce out to the return, and we leave. So let's check to make sure that that prevented the network call from being made. So if we reload the page, clear this out, hit rant, not seeing any new requests being made. So that should calm down those server guys. So we used the network inspector to look at who was making requests and troubleshoot back to the original code that was causing it. And then we used the JavaScript debugger to fix it. And the root cause of this is that we were sending data up to the server that it didn't really expect. It didn't conform to its expectations. And so we just needed to use the client side to make sure that we stopped ourselves from submitting invalid data. All right, bug number 4. We have some unexpectedly high memory use. So there's not, Get Ranter is obviously one of the most epic and prolific apps of our generation. But in terms of code, it's not all that complex. So we shouldn't be using gigabytes of memory for what we're doing. But we're hearing things about slowing down our users' machines and using multiple gigs of memory inside of Chrome tabs. And so that kind of sounds like a memory leak. So let's see if we can find a memory leak inside of Get Ranter. And so to do that, we're going to look at a couple of different things. We're going to look at the profiler, we're going to look at the timeline, and we're going to obviously look at the JavaScript debugger to see if we can fix it if we can find one. So let's kill this bug. All right, so we're going to reload the page, make sure we're in a clean state. So the first thing we're going to do is let's prove to see if there is a memory leak. Kind of proving whether it's a memory leak is easier in one tool versus finding a memory leak is easier in another tool. So let's prove it first. So first I'm going to go to the Audits tab. No, I'm not. I'm going to go to the Profiles tab. The Profiles tab lets you take different kind of profiles of JavaScript utilization during the page lifecycle that is interesting to tell you different kinds of things. And it even gives you a little snippet of information about each one, about what each one is good for. And so the one that we want to use right now is the record the allocation timeline. What this lets us do is it lets us record when is memory allocated for JavaScript and when is it freed. So if we just turn that on, and let's just record the usage for a little while. Let's see if anything is happening over the lifetime of the page. Ooh, we got a little spike of something. Let's watch it maybe a little bit longer. Oh, there it goes again. Let's just give that a stop and we'll kind of go through it. So there's a lot that's going on this page, and a lot of it's really detailed, and you don't really need to care. What's interesting is you look at the chart on the top, and you just kind of zoom in on the parts that show up as interesting. Like the parts that are just a great big flat line are not all that interesting. But these parts are kind of interesting. So you can just drag a selection around it and say, all right, well, what was that? What was going on? And what it's telling us is that during this particular time period, memory utilization increased by 82.9K, which isn't a lot, but it's a little bit, and it seems to be happening every 10 seconds or so. We can look and see what were the, let's get rid of that. Slide this over a little bit. So we can look and see at this, and why isn't that going over? There we go. Whew. Where? I was losing my mind. So here, during this time frame, it shows us all of the different actual things that are consuming that memory. And it's not really interesting to go through and explore all these. A lot of these are very low-level things. Basically, anything in parentheses here is like a low-level object that you're probably not going to be able to reverse engineer and figure out what it is. But the other stuff might be interesting. So let's take a look at what are some of these objects. So some of these objects here are consuming a fair bit of the memory. It's a big part of the retained size that we're seeing. And so these objects, I don't really know what they are, but they have this thing called an advertiser ID, and they have an image URL, and they have a target URL. That kind of, maybe that has something to do with advertising. So I feel like there is a memory leak here. Like, we are seeing an increase in memory over the time period of the page. So over the time period that we recorded this, we're seeing an increase of about 100K. And so if we had people who are using Ranter for like hours or days, this could actually start adding up to like real amounts of memory here. So in order to figure out where these leaks are coming from, I have an idea that it has something to do with advertising. But to get a better idea, I want to use the timeline. Now the timeline allows us to get a very low, a little bit higher level view than the profiles, but a view into what JavaScript is executing and what the browser is doing at each given point. And so in order to find these kind of problems, what I want to look at is I want to look at the JavaScript, and I want to look at the memory utilization over time. And so I'm going to just turn this on, and we're going to capture some of the timeline over the same kind of maybe 10, 15 second period. So there we go. We got a little bit of data, 15. All right, let's take a look at what we got. There's, again, a lot of information on this screen, and you don't have to digest it all at once. Think of it as a drill down. The top shows us this general timeline measured in milliseconds over the period that we captured. And it's got some high-level statistics about what was happening. So we can see in blue the JavaScript heap allocation over this time frame. We can see in gold the number of event listeners attached. And we can see in green the number of HTML nodes that exist at this time. And using this, we can kind of drill in on where are things changing. Because that's the point where memory leaks can happen, is where are changes happening that might not be getting cleaned up. And so we can just go ahead and zoom in on this. So I want to look at this period right here. This period right here, we're creating a lot of nodes, we're creating a lot of listeners, and the memory utilization is ticking up, and it looks like it gets cleaned up, but the heap already proved that like over time it is ticking up. So the fact that we have a decrease here is kind of a red herring. But so as we look at this area, the area below starts showing up each individual thing. And we can just keep zooming in on this area. So it even supports key commands. So if anybody's like a video gamer, like WASD is your classic navigation here. So like just like a first-person shooter, you just kind of like zoom in on the area where like more and more interesting things are happening. And as you get closer, you actually start seeing that we're like measuring in milliseconds at this point. But here's where we're actually seeing what JavaScript functions are doing and what are the impact of those JavaScript functions on the behavior of the page. So you see that the JavaScript functions that are yellow are involved in creating listeners. The JavaScript functions that are blue are involved in increasing the JavaScript heap size. And both of those things are big factors in terms of the overall memory. The memory of the system is both in terms of JavaScript heap, of what variables are kept, but also the size of the DOM, the amount of JavaScript nodes that exist. And so we can look through here and scroll down and see all the different things that are happening. And the darker the color, the more prevalent it is. So we see a couple of like really dark anonymous functions here. Maybe we'll take a look at one of those here. If we go even farther down into the summary, we see anonymous and unknown. That's not very interesting. Prepend, rent. Okay. So here we see a whole bunch of different things happening. We see a render function, which is creating nodes. A bunch of anonymous functions that are increasing JavaScript heap. Some more render functions that are creating nodes. And ultimately, some gold things creating listeners. So let's look at the root kind of the problem, which is the creation of nodes. We see a render function here, which if we keep digging down through the data, eventually we get to a summary, which points us directly at the line of code that is being executed that represents that bar in the graph. So if we take a look here, here's the function in question. We're seeing a file called add list view. And so the add list view looks like it's going through a collection of ads, and for each one, it's trying to render that ad. So then when we highlight this, it points us at the function below. So we see a render ad, and an ad is creating a new ad view, and then it's rendering that. So an ad view looks like it's right up here, add view. Add view renders itself, and right here we see something interesting. Here, after we've rendered it, we look for anchor tags, and we attach a click handler to those anchor tags. Now that click handler creates a pointer to the DOM. And so every 10 seconds or so, these ads are changing out. And so these ads are changing out, but they still have click handlers pointing at them, which means even though we're throwing away the ads, that bits of DOM, those bits of markup, are still floating around in the page. Putin is just all over this page, floating around in cyberspace, just waiting for somebody to click on him, but he's not visible anymore. But that's what's consuming all of the memory. Now, in order to fix this, I think we would have to work with our advertiser a little bit, because they probably want to know more about their click analytics. But this is a pointer to what we need to do, is we need to find a way to detach this. Now, there's not a good way to fix this thing, and we're running short of time. So I'm going to move on to the last bug. This bug should be fixed by, we need to be able to detach an event listener when we're cleaning up the ads. But we'll let the interns take care of that one, I think, right? So this bug, we looked at profiling, and we looked at the timeline. And then we played around with the data in the JavaScript debugger. The root problem was we weren't releasing events, even though we were destroying the DOM. All right, last bug. Sometimes the page is slow. That's real vague, huh? Sometimes it's slow. So we're going to take a look at the timeline again, but this time we're going to focus the timeline on understanding the performance of our page. And what are the things that it's doing that could potentially be slowing down our load time, and what things we could do to fix it. Let's just reload this, make sure we're in a good state again. Probably just close all of you. All right, so let's open up the timeline. I still got our previous session here, but let's just get rid of that. So this time, because I'm interested in performance, I want to know about a whole bunch of things. So let's go ahead and I want to know about the network. I don't really so much care about the JavaScript profile anymore, because that's not really a key part of the performance, I don't think, here. But I want to see some screenshots. I don't really care about memory, but I care about the paint time. So I kind of just inverted this. I want to know about how long do we take on the network, what does the page look like over the course of its operation, and what are the different times it takes to paint my page. Now we're interested in what's happening on load. So with these things turned on, anytime I just reload the page, the timeline will just start recording automatically. So I'm going to just reload the page, and it should record here for a few seconds, and we get a breakdown of exactly how the page loaded. Now, I render most of my stuff here off of localhost, so stuff is really, really snappy for me. But we can extrapolate out this data as though somebody on a much slower connection might be experiencing it. In fact, we can even simulate that. If we backtrack over to the network tab, Chrome allows us to pretend to be slow. So let's pretend to be slow. Let's pretend that we are on a good 2G connection, which should be like pretty slow at this point. Does anybody still use 2G here? Only when you're on the trains, right? So let's turn that on, and let's maybe give this a try again. Now, this isn't foolproof because it is simulated, but it should give us like some idea of how much slower things take. I mean, and it definitely was slower when we did that. So we have a little bit better idea of how our customers might interact. So over time here, we can see like at each time slot, here's how getRanter renders to the user. You know what? Let's do this one more time. Let's scroll this over so that getRanter actually shows well. I probably should have spent a little bit more time. We probably have a little bit of work to do on responsive design, you know. But right now, Trump, you know, he's mainly a desktop kind of guy, so hasn't been a top priority for us just yet. Oh yeah, that is kind of slow, huh? All right, so let's now take a look at our timeline. So we can see here at each given phase, what did the page look like at this stage of its load? And so we see we get the header come in at about 1,000 milliseconds, and it stays that way. We don't really get anything else until about 5 seconds in, and then the left side starts drawing out. We start knowing about that. And then we get the timeline, that fills in. And then at about 6 seconds or so, we start getting pictures. The ads still haven't loaded yet. Ad networks are awesome and fast all the time, right? But by the time we get to the end of our timeline, we still don't have our ads loading here. And so we can kind of break down that there's a couple of different phases of load time here. So in the next section down, we can actually see what was the page doing during each section of time. So let's zoom in again and get a smaller sample. So at the very beginning, we start loading localhost. There's not a lot we could really do to improve that. We have to load, the original page. Maybe you could put it yourself on a CDN and do like some edge network stuff, but that's a really hard infrastructure thing that I'm going to leave for like when we need to hit web scale with this sort of stuff. Then we have to load a whole bunch of stuff. So we're reaching out and talking to fonts.googleapis.com. That's kind of harsh. Fonts.googleapis isn't always the fastest thing in the world. Maybe we could pull that locally. And then we have some CSS files that aren't so good. It takes like 400 milliseconds. And we have all of these different pieces of JavaScript that are coming down. That's probably not so good either. We could probably improve this quite a bit by like taking all those JavaScript and like smashing them together. Doing some concatenation, some build time processes to do that. It just hasn't hit the top of our priorities with getRanter just yet. But we're spending a lot of time here just loading JavaScript on the page. The app isn't really very functional until JavaScript is on the page. So maybe we should think about our architecture a little bit and see if we can, shove down the initial timeline, maybe on first load, so that the user has something to do. Or if that's too hard, at least maybe a little loading spinner, a little Trump GIF spinning around in circles or something like that. That might be a little helpful. So then a little bit farther down, we see that we're pulling down another file from Google, this fonts.gstatic, and this takes 1.38 seconds. So this is fairly slow to pull down this font. But it's like blocking the page, we haven't rendered yet. So maybe we could make this asynchronous. I mean, this is a design choice. Fonts are often quite large, but if you wait until after page load, you have that annoying flip where you see the fonts change from one font to another. I imagine you've seen this on some web pages. That's a performance decision that you have to make. Do you want to slow down the whole page so that the user sees the font you want? Or do you want to get the content out fast and you can flip the font later when you have time? Let's keep going through and see what else is going on. So at this point, we still haven't rendered anything. We're still loading JavaScript. jQuery is still coming down. jQuery is huge. Maybe we shouldn't use jQuery. Do we have to support IE8? So now we're making some AJAX requests. We're pulling down some ads. We're pulling down some users. And we're pulling down the rants. And those are probably things we have to do. But again, we could make some choices about maybe we should inject those things onto the first load so that we don't have the back and forth of pulling down a page and then making an AJAX and then pulling more data and then rendering some stuff and then pulling more data. Maybe we should just figure that all out server side and ship one finished page on the initial load. So then we pull a bunch of images. And these images, it says the impact is fairly small, but we're spending a lot of time there. There's some things we could probably do there around rendering blurry images or a two-phase image approach. Facebook does a lot of that, and we should copy Facebook. So that's the general behavior that we're seeing here. So there's a couple of different things we can do. We can decrease the size of our images. We could bundle some of our data on initial page load so that the user experience is faster initially. We should consider maybe getting rid of these big JavaScript libraries that are taking a long time to download. And we should definitely bundle all of this JavaScript together so that there's fewer things that come down. All of those things together could make this page a lot faster. Fortunately, these are all probably conference talks onto themselves. Hopefully somebody else is talking about it. I know I've seen NDC videos. A good friend of mine, Nick Molnar, had recorded one in Oslo about 6 months ago on web performance. Talked all about all of these things. So what we did today is we looked at the timeline to see what are the things that are blocking page load. And the couple of things that we can do is we can look at how do we consolidate fonts, how do we get rid of big page libraries, and how do we compress our assets down. And so these are some good things that you need to think about if you're building large-scale web applications that need to be delivered quickly. So here's all the things we talked about. I'm running about 55 minutes, so we should be good. We looked at the DOM inspector and how to look at an element and see what are the JavaScript things that are listening to that element and how to navigate starting from there, which can be really helpful when your user tells you a bug involving the visual elements versus the code. This is how you enter the code from the visual representation. The JavaScript debugger itself, stepping through code, looking at the local variables, understanding its context. The application explorer lets us go in and see what are the pieces of data that are actually stored in the browser. The timeline lets us do a couple of different things. It lets us diagnose memory leaks to figure out where things are coming from, but it also helps us understand general performance. And so it's one of the most valuable pieces of Chrome DevTools, and it's one of the least understood. And finally, the profiler helps us prove whether or not memory leaks exist. For other scenarios, it also lets us do things like understanding CPU utilization if you have a high processing JavaScript app. When I'm not doing this, I work on Track.js, which helps you understand when your users are running in bugs in production. If you'd like to check us out, we have a booth out there, and we do all kinds of cool things about giving you like really detailed error reports and understanding when things fail. And if you'd like to give that a try, we're out at trackjs.com. This was Squashing JavaScript Bugs. I hope it was fun. I hope you learned something. I have a bunch of squashed JavaScript stickers. Feel free to take one and give me a green card. Thank you very much.